Welcome back. Problem 11-7. So statement is draw the shear and moment diagram for W12 by 14 beam and check if the beam will safely support the loading. Take allowable bending stress is 22 KSI and allowable shearing stress is 12 KSI. So you can see this is the beam. At this point there is a moment of 50 kips into feet. From point A to B, there is a uniformly distributed load of 1.5 kips per feet. A to B distance is 12 feet, while overall length of the beam is 15 feet. Clear. So W12 by 14 wide flash beam is given from the property of table or from appendix B. At the end of big beam, we will get its section modulus, its depth and thickness of web. I will show you. This is the property table. You can see that W12 by 14 is given over here. So its section modulus is 14.9 cubic inch, while its depth is 11.91 inch and thickness of web is 0.2 inch. So note down this value. I have already written over there each values, and allowable bending stress is 22 KSI and shearing stress is 12 KSI. So we will draw the shear force and bending moment diagram, and then we will check whether the beam is safe or not. So first step in solving is this problem is if we remove the support at point A, so definitely there will be a reaction force at point A, and if we remove the support at point B, so there will be a reaction force at point B. So we will find this reaction force. How we will find them? So first equation is sum of all moment about point A is equal to 0 and taking the counterclockwise moment as positive. So about point A, there is a moment of 50 kips that is counterclockwise. So I will write it 50. The second moment is due to this load RB into perpendicular distances 12 feet, and this is counterclockwise, so it will be also positive. So plus 12 into RB. The third moment is if we convert this distributed load into a point load, so it will be 1.5 into length, which is 12 feet, and this will be acting at a distance of 6 feet, that is 12 by 2, and this will be clockwise moment. So this moment minus 1.5 times total length over which it acts 12 feet and perpendicular distance is 6. Their sum must be equal to 0. So when you solve this, you will get RB is equal to 4.83 kilo pound. Now you have RB, you can calculate RA by using this equilibrium condition. Sum of all forces in y direction must be equal to 0. So one force is this one plus this one minus, if you convert this distributed load into point load, that will be 1.5 multiplied by 12. Their sum must be equal to 0. So RA plus RB, which is 4.83 minus 1.5 into 12 is equal to 0. So when you solve this, you will get RA will be equal to 13.17 kip. Now you have both RA and RB. We will move toward drawing the bending shear force and bending moment diagram. So I have already drawn here the free body diagram of this beam. You can see this is a 50 kips at a distance of 3 feet. Let I have taken each box is of 1 feet, so this is 3 feet. This remaining is 12 box, so it is 12 feet. And you can see automatically this is 6 box, so it will be 6 feet. So we will draw the shear force diagram. You can see at point A we have, you can see at this point at free end, we do not have any shear force. So from this point till 3 feet there will be no shear force, and at a distance of r 3 feet we have RA, which is upward, and R is 13.17 kips. So at 3 distance we will take 13. So I have taken each box is 5 kips. So this will be 15 and 13 will be somewhere here. So this is 13.17 kips. Now from A to moving from A, you can see this is moving from A till end. There is a uniformly distributed load of 1.5 kips per feet. So if 1.5 kips per feet is multiplied with 12, so 1.5 multiplied by 12 will give you minus 18 because it is downward. So plus 13.17 minus 18. 13.17 minus 18 will give you 4.83 minus 4.183. So at the end this will be, this is minus 5, so end will be somewhere here. So if I draw, if I join them by a straight line, you can check that this shear, the uniformly distributed load is a horizontal line with 0 degree, so shear force will be 1 degree higher, and as it is negative, so slope will decrease. So this will be your point. So if you draw it, it is digital, so it will give you some error. So you can check that this will be your required point. The reason why this point is shifted, that this is not exactly the same 13.17. Okay, so this will be your shear force. Shear force from 3 will change to 13.17. Why? Because at point A we have RA, which is 13.17, and then it will start like this. Now you will, when you draw it carefully as per scale, you will find that this is 11.78 from the start, so feet. So at this point the shear force will be 0. Now we'll draw the bending moment diagram. Now at this end you can see there is a 50 kips into feet that is given. So now we have a rule that if you have external movement that is counterclockwise, so in bending moment it will go downward. There will be a decline in the bending moment, so it will be here, it will be denoted as negative. So at this point bending moment is 50. Now you can see that from this point till this point there is no change in bending moment, so it will remain same. So till point this it will remain same. Now here you can see this is the area under the shear force will give you a bending moment, and this area will be equal to 1/2 into 13.17 into this base, which is 11.78 minus 3, and that is 8.78. So when you multiply it, it will be equal to 57. When you multiply it, it will be 57.81, and that will be minus plus because this is positive area. So here we have minus 50 plus 57.58 will give you 7.79. So 7.79 will be somewhere here. Again you can see this is first degree, the slope is decreasing, so bending moment will be a second degree and it will be clockwise. So we will join them. It should be a curve in curve form. So this point is 7.78. 7.78 kips into feet. Now the third area is this one, so you can see this will be equal to this portion, which was 4 point, I think there is minus 4.83 into this remaining distance, and this remaining distance will be equal to 15 minus this 11.74. when multiply with this divide by 2 will give you plus 7.78 minus 7.78, because this is negative. So at the end bending moment will be 0. So this will be also in the form of curve, because this shear force is a first degree line and the slope is decreasing, so bending moment will be a curve. So this is the bending moment diagram. Now we will quickly move toward our required problem. We know that maximum bending stress is equal to maximum bending moment divided by section modulus. So you know that maximum bending moment from here is minus 50, and we will take the mod. So 50 kips into feet. So if we convert it into inch, so 50 into 12 divided by section modulus was 14.9. That is given over here. So when you calculate it, you will get maximum bending moment comes out to be 40.27 ksi. But we have given allowable stress is equal to 22 ksi in our given data. So our maximum bending stress is greater than allowable. So it means not good. It cannot bear the bending load. We will also check for shear stress, and then we will conclude. We know that maximum shearing stress is equal to maximum shear force divided by thickness of web into depth. So you have all the value. Maximum shearing stress is 13.13. 13.13 divided by thickness of web was 0.20 and its height was 11.91. So when you calculate it, you will get maximum shearing stress comes out to be 5.53 ksi, which is less than tau allowable, because tau allowable was 12 ksi. So here in term of shear stress it is okay, but in general you can see that our maximum stress is greater than allowable. So hence we can say that wide flange W12 by 14 fails due to bending stress and will not safely support loading. So we cannot use this W12 by 14 beam for the given loading. I hope you have enjoyed this video. If you have any question, you can ask me in comment section. Those who are new to my channel, then subscribe it and press the bell icon so that you can get the notification about my latest video. Thank you for watching.